So let us discuss about signal flow graph, right? So already we have been discussed about what I can say black diagram reduction technique, right? Of course, it's a simple tool, right? When we have more number of blacks, physical variables cannot be realizable. Input source not known, output value not known. But you can say, you can once the thing is what type of energy that has been given at the input side, that is not known. But because black diagram in the sense, what we can say, physical realizations could not be possible, right? Just we can visualize some blacks are there, sir, and just that will be given to you and you can reduce it. But what we know, you know how to reduce the things, right? But physically what is beginning of the things, that is adu namak theriyadu, right? That will be what adu neenga enna pannom, you have to go beyond the mathematical modeling, sir. What is the actual physical system, how it was being developed from there, you have to develop from there, right? So in black diagram, even in exams also you cannot that is what I can say, it won't be physically interrupted. Some things will be there, some black will be given to you and you are supposed to reduce the black. At last what you are just pass some input signal, test the output. Just each and every time a big complicated system will be simply analyzed with the help of different input signal and different output signals. That's all, right? So the thing is, in my black diagram reduction technique, even while going with the black diagram reduction technique, some systems are highly complicated. They are unable to, what I can say, if some type of systems are cannot be analyzed directly, if it is too difficult with the black diagram reduction technique, then the simplest, easiest technique will be there, that is called a signal flow graph. With the signal flow graph we can reduce the functions, right? Let us see the beauty of our signal flow graph. In the signal flow graph we will get the clear idea, right? So listen, what we are going to do in our signal flow graph, very simple, very simple. Once again, for that I am just giving some introduction, right? Just learn the techniques whichever that I am giving here, because physical interruptions cannot be realizable directly. First we should get the grip with the systems, right? Okay sir, some blacks are there, how to reduce the black. At last, and finally what will happen, if 10 blacks are there, 10 blacks can be put into the single black and then you can test the system overall individual performance. Individually each and every blacks can be tested, overall system also can be easily tested with the help of signal flow graph. That is the beauty, right? Okay, it is same as our what I can say black diagram reduction technique, but I said if it is too difficult, some blacks are not cannot be directly analyzed with the help of black diagram reduction technique. In such a way, in such cases you are supposed to go with the signal flow graph, right? Let us start. So in signal flow graph, first you should understand something, right? Already we saw the meaning of take a point in black diagram reduction technique. We saw the meaning of what I can say summing point, right? So here in signal flow graph, all the points, if I have a take a point, that point can be treated as a node. That point can be simply treated as a node. Sir, I have a summer. Just replace the summer, right? Just replace the summer by a node once again. That is also going to be treated as a node, single node, right? You can simply, this big black will be replaced by this big comparator will going to be replaced by a single node. Clear? In signal flow graph. Okay sir, next what we are going to do, I am going to assign some variables. Let us see one by one. So in signal flow graph, once again we are going to discuss about the paths, right? If your path will be represented like this, arrow mark, that arrow mark indicate what? That is the direction in which you have to travel, right? If I reverse the direction, you cannot flow, right? எந்த direction represent பண்ணிருக்காங்களோ அந்த direction மட்டும் தான் என்ன பண்ணணும், you have to travel. You are not supposed to travel in the opposite direction. That is very very important, right? And next thing is, here I am introducing few more things. என்னன்னா அப்படினா, in our black diagram reduction technique, input is called source, right? Input in the sense, see, now I have a system like this. For example, I have a branch like that. In that branch, it was given as this is called reference or input. Input is nothing but what? Our source or energy point, right? This is my input point, right? So your input branch will always, input or work, it has to supply some signal to the system, right? So always from the input your signal has to leave. Always signal has to leave away from the input. Should try to understand, always your input will going to supply the signal to someone. In the sense, your input has to supply always from the input, your signal has to leave away. Your signal has to leave away. Arrow mark இப்படி தான் போடணும். Suppose sir, given it is a input system, this is the input, given this is input, right? Input is given, whereas we have a self loop. Whereas we have a self loop. But what I have told you, the purpose of input is it is going to supply some signal to someone, right? But here they are given a self loop. This is called a self loop, right? What do we mean by loop? right? If a person, right? Loop in the sense, if the starting point or the originating points are same, then that is called a loop. See, I am starting here. After completing the all things, after traveling all these villages or somewhere I went, right? In the two, again I came back to the same point, right? I came back to the same point where I have started. That is called a loop. If starting and ending points are same, then that is called a loop, right? But the thing is, what is the purpose of input? Your input has to supply the signal to someone. But here what happened? Some self loop is given. So in signal flow graph, at the input side, always your signal has to leave away from the input. Suppose if you find any self loop, you no need to consider. You can remove it from the block diagram. Guys, listen. Once again, I am repeating. While calculating the transfer function from the signal flow graph, if there is any self loop at the input side, you no need to consider. You can remove it. First conclusion, right? And the second thing is, if there is a line, right? If there is a line, that line is given like this, right? If a line will be directed from input to output point, if a line will be directed from input line to output line, you can just travel that is, you can just track the path. Arrow mark will be given. In that arrow mark, if the arrow mark will show the path to the output from the input. If any arrow marks, right? In some branches are there, right? In that branches, some arrow marks are there. That arrow marks shows the path to the output from the input. They are called forward path. That branch is called forward path, right? That line is called forward path. Forward path in the sense non-repeated, right? So I have to select some branch. In that branch, right? Non-repeated points are there. Non-repeated in the sense, now I am crossing the point 1. And then I am crossing the point 2, and then I am crossing the point 3, and then I am crossing the point 4. 4 points were given with the arrow mark. Now I am just going with the points, right? Non-repeated in the sense, forward path is called in which nodes are not being repeated. And the second thing is, you have to reach your output from the input directly. Without, right, in your path, your roots are not in your path. Your nodes are not being repeated, right? In the sense, if I start from here, I will go here. That node 1 had been crossed. Now I am crossing node 1, again crossing node 2, node 3, node 4. I am reaching the output. Is there any nodes being repeated? No. So this is called forward path because here my nodes are not being repeated. So what we are trying to conclude here? See, suppose if I have one more branch, it had been given like this. Now this is node 1. Now arrow mark will be given like this. Now you can start from here directly. You can cross this node and you can reach your output from input. This is called forward path. But if I go here, you can also go like this. You can go like this and you can also go like this, now. But that is not correct. Why? Already, when the moment you are coming here, you are crossing this node. Now I am taking in this path. Again I am getting back to the same node and then I am going. Such type of paths cannot be considered as forward path. Should try to get the clear idea. Forward path in the sense, non-repeated nodes path will be treated as a what? Non-repeated nodes path only treated as a forward path, right? And the next thing is output, right? So input is called source, output is called link. Now what we are going to do with the link in the output side, right? When the moment I am calling it as output, so right, is when the moment I am taking your output, right? Output some signals is going to be linked with your output, right? So your output, and sometimes we are also calling it as sink. Right? Now in this sink, what I am going to do? We are going to collect the energy. Okay, just remove this one. Just consider sink, that is unusable because that word is not often used in our exams. Right? So I am going with the sink. So output is can also be called. Just consider sink, that is enough. Right? That links are not available because sometimes you might be get confused. So sink is the general name. Let me consider. Input is called what? Source. Output is called what? Sink. Right? So in the output side, what I am going to do? I am trying to collect the energy. Of course, sir. So output it will collect the information from the system or from the input. Through the system, it will collect the information. So always in the output node, your arrow mark will going to be terminated. I am repeating once again. Your arrow mark will always be terminated into the loop. If your arrow mark will be terminated into the loop, then you have to consider that one. Clear? So arrow marks will be terminated into the loop. That is very important. Arrow mark will be terminated into the loop. Suppose, sir, I have a loop like this. You can consider why arrow mark is terminating. It is starting here, of course, it can terminate here. But what I said, input side, your signal has to leave away. It has to go away. But in the output side, if your link is entering, okay, that is acceptable. Because output is waiting to collect something. But your input is waiting to deliver something. In the sense, I cannot keep self loops here. That is not acceptable. Clear? That's all, right? So that is the basic things. And the next thing is, let us understand the meaning of loop and what I can say, integer loops and non-touching loops, right? Two non-touching loops, three non-touching loops. What is the meaning of them all, right? Now I have a path like this. Some path will be given like this, right? In that path, some loop will be given like this. Sir, some loop will be given like this. Listen. Now in this line, how many loops are there? First thing is integer loops. What do you mean by loops? First, trace the arrow mark. It will be given in your exam. Arrow mark will be given, right? In our system, some signal will be given. That signal black will be given. That black arrow mark also will be given with the values. It's like -2, some -3, 1, 2, 3. Something will be given like that. You can just trace the path now. Now the thing is, what do we mean by loop? What do you mean by loop? Loop in the sense you have to start, right? Loop in the sense starting point and terminating point are going to be same with the non-repeated nodes, right? If I'm starting from here, you can form a loop, right? Loop can be created without repeating the nodes, without repeating. That is, repeated nodes not allowed when we are creating the loops, right? While creating loops can be created without repeating the nodes. So what I can suggest, let me call this one as a node, let me call this one as a node, let me call this one as a node, and just keeping some name, that's all. Don't think too much. Some name that I am giving, right? Now I am starting from node 1. I am crossing like this and just going. See there, you can go like this because arrow mark is given in this direction. I can come here also because arrow mark is given like this. Again, I am reaching this. See there, I am crossing node 1. I am starting at node 1. I am crossing node 2 once, and then I am getting back in this way. Again, I am reaching this same point. So this can be treated as a loop. This can be treated as a loop, right? Now, loop in the sense starting and the terminating point must be remain same, right? In the loop, repeated nodes are not available. That is not allowed, right? You can say repeated nodes are not allowed, right? Such that, see, you can start from here, you can go like this. See there, let me give arrow mark in this direction. You can close a loop here, you can create a loop here, right? Loop in the sense starting and terminating points are going to be same. Starting and terminating points are going to be same without repeated, that is without allowing repeated nodes, right? See there, I am crossing this node only once, right? And again I am terminating where I have started. So starting and terminating points are going to be same in a loop without allowing repeated, repeated nodes. That's all, right? So that is called loop, right? So the thing is, so what you are trying to say, for example, let me take one more conclusion. If I have a loop like this, right, something given like this, and they are coming like this. Given this, let me go here. Let me name them node 1, node 2, node 3. Now here, how many loops are there? Right? If you are asked like that, let me say only one loop, two loop will be there. How can I say? See, I am starting from here, you can go like this, you can coming back. It can be treated as a loop. See there, node 1, I am crossing, I am going here, node 2, I am crossing once, I am starting from here, I am crossing node 2, again I am getting back where I have started. So starting and terminating points are same, so loop 1 will be created. Again see there, I am starting from here, again you can go like this, you can getting back here. This can also be treated as a loop. But the thing is, sir, I am starting from here, I am reaching here, I am reaching here, again I am getting back. Here also, the arrow mark இப்படி தான் சார் கொடுத்திருக்காங்க. அப்ப இதையும் ஒரு லூப்பா ட்ரீட் பண்ண கூடாதா? That is wrong. Why? Because see there, I am starting from here. I am crossing this node once. 2 நீங்க cross பண்றீங்க. திரும்பவும் see there, I am coming to 3. Again I am getting back. Once again we are touching the node 2. I said while creating the loops, your repeated nodes are not allowed. You have to touch each and every node only once. Already we have been crossing this node. So once again you cannot touch that node. Clear? So only 2 loops will be there. That is how we are creating the loops without creating. That is without what I can say, keeping more than. That is without allowing repeated nodes. Clear? That's all. Clear? Next thing is, what do we mean by non-touching loops? Non-touching in the sense, common nodes are not there. In any loops, if there is no common nodes, then they are called non-touching loops. For example, I have node 1, node 2, node 3, node 4. Like that I have something, right? Now here let me go like this. Here one will be given like this and here one will be given like this. If you compare these two loops, so I have loop 1 with the node 1, node 2, we are creating one loop. With the node 3 and the node 4, we can create one more loop. Now see there, to create the loop 1, I am using node 1 and 2. To create the loop 2, I am using node 3 and node 4. Is there any interconnection between them? No. In this case, I am using node 3 and node 4. In this case, I am using node 1 and node 2. So this is called non-touching loops, right? This is called non-touching loops, right? I hope you all understand. So this is called two non-touching loops. Then what do you mean by three non-touching loops? Three non-touching in the sense, suppose I have one more loop here. Like that is a number of loops can be considered. Sir, this is name it as 5 and 6. Now you can create one more loop here. Now see there, to create this loop I am using node 5 and node 6. Now see there, node 1 will be interpreted to 1 and 2. Loop 2. Loop 1 will be interpreted to 1 and 2. Loop 2 will be interpreted to 3 and 4. Loop 3 will be interpreted to 5 and 6. So what will be the conclusion here? This is called three non-touching loops. This is called three non-touching loops. That is over, right? I hope you all understand. Now we should get the meaning of gain, product gains, right? Gain products. What do you mean by gain products? So in our signal flow graph, very simple actually. Bringing the answer to the signal flow graph is very easy. Some basics are there that it should be required to get the clear idea when the moment you are visualizing the questions. That is very simple, right? Now what do you mean by gain product? For example, I have a forward path like this, right? I am just going from R to C. There will be a forward path that has been given with some nodes. Node has been given. Some nodes has been given, right? Forward path will be given like this. Here on forward path in the sense what? You have to start from R, you have to terminate at the C. Right? That is called a forward path. It will be directing. It will show the path to reach the output from the input. That here on will let you. It will show the path to reach the output. That is called forward path. Now, what do you mean by gain products? Right? Gain product in the sense, in the forward path, some gain will be given. Like in this forward path, here we have 4, we have 2, 1, 3, some value given like that. Right? Now, gain product in the sense, let me call it as, I would like to know the gain of this forward path. Gain of this forward path. In this forward path, how many gains are there? 4, 2, 1, 3. So, the total gain product in this forward path is going to be 4 into 3 into 1 into 3. That's all. That is called gain products, right? In the forward path, what will be the gain? Overall gain. In the sense, you have to simply multiply them all. Now, what will be the answer? 4 times of 2 will be 8. 8 into 3 is what? 24. That's all. That is how we are bringing the answer. So, gain product in the sense what? You have to multiply all the gains. That's all, right? Now, what is the product of the loop gains? Right, sir? One loop will be given like this. One loop will be given like this. Loop 1, that is I am passing node 1, node 2. We are creating the loop. Here, in this value, here it is given as 1 plus 4. Here it is given as minus 2. Now, when the moment we are finding the loop gain. Loop gain in the sense, just what you have to do? Just to find out the integers or some values available in your loops. Whatever the things that will be there, loop gain in the sense, just multiply all the gains. Given this gain, given this gain. So loop gain in the sense, in that loop, how many gains are there? Product of loop gain, that is called product of loop gain. 4 into minus 2. So your answer is going to be minus 8. That is called loop gain. Right? Now, what do you mean by non-touching loop gain? Right? Two non-touching loop gain. Meaning of two non-touching loop gain. Let me say two non-touching loop gains. Right? Two non-touching loop gains. Abhina meaning is, sir, I have a forward path. I have a forward path. I have a loop here. I have one more loop here. Now, what do you mean by two non-touching loop gain? In the sense, one node will be given, one more node will be given. Let me consider one more node here. Now, here gain value is given as 2, return path given as minus 2. Here gain value is given as 3, here it is given as plus 1. Something will be given. Now, question is gain, that is, the question is gain product, right? Gain product of two non-touching loops. Gain product of two non-touching loops. There are two loops, they are not touching each other. See there, loop number 1, I am using, to create the loop number 1, I am using node 1 and node 2. To create the loop number 2, I am using node 3, node 4. So they are not interconnected each other. So the question is what? Product of, gain product of non-touching loops. Gain product of two non-touching loops. Gain product of two non-touching loops, right? So these two loops are not touching each other. So gain product in the sense, first multiply the loop 1 gain. Loop 1 gain 2 into minus 2. That is minus 4 into, see, gain product in the sense, gain product, gain of loop 1 into gain of loop 2. Loop 2 gain 3 into 1, 3 into 1. So that is going to be 3. So minus 3 into 4 is going to be minus 12. So gain product of two non-touching loop. Very important is two non-touching, right? You are not allowed them to touch each other. That is the meaning of gain product of two non-touching loop gains. Sorry, gain product of two non-touching loop. Suppose then what do we mean by gain product of three non-touching loop? So there will be one more loop like this 5, 6, and it has been given 1 and 2. Now this is called three non-touching loops. See that third loop has been created with the node 5 and node 6. Right? So the thing is there is no interlinks between the three loops. That is called gain product of three non-touching loops. Gain product of first loop is minus 2 into 2, that is 4, right? First loop, second loop 3 into 1, third loop minus 2 into 1. So that is called gain product of three non-touching loops. Gain product in the sense you have to consider three loops and you have to multiply them together. That is called gain product of three non-touching loop. That is going to be 3 into minus 2 minus 6 into minus 2 will become minus that is plus 24. So that is how we are finding the gain product of three non-touching loops. In the same way, you can also find four non-touching loops, five non-touching loops, like that. Right? Now, next we shall think one more thing. That is, once again, loop gain of, that is integer loop gain, right? Integer loop product, that is integer loop gains which are not touching the selected forward path, right? Integer loop gains which are not touching the selected forward path. In the sense, for an example, I have two forward paths here, right? I have two forward paths here, forward path 1 and forward path 2. I have two forward paths. In the forward path 1, they are given a loop. Forward path in the sense it will going like this, right? And it will going to be like this, right? Once again, they are going to reach output. Now, what do you mean by forward path? What do you mean by forward path? Let me explain once again. Wait a minute. Let me explain once again. Forward path in the sense I have to start from the input, right? Forward path in the sense it is the showing the path to reach the output. See there, I can also go in this way. This is one forward path. This arrow mark indicates the path to the output. You can also go in this way now. See there, this is also, this arrow mark also helping us to reach the output. So I can go, you can reach your output in two ways, right? This is forward path 1 and this is the forward path 2, right? Now the question is loop gain which are not touching the selected forward path. In the sense loop gain, right? Gain product, loop gain product. Let me call it as loop gain product which are not touching the selected forward path. Make a statement clearly. Loop gain product which are not touching the selected forward path, which are not touching selected forward path. Sir, abdina meaning enna? See, if you are analyzing the property of forward path 1, forward path 1 oda property neenga analyze பண்ணிட்டு இருக்கும்போது நான் ஒரு क्वेश्चन கேக்குறேன். See, find out the loop gain product which are not touching the selected forward path. இந்த forward path கூட நீங்க டிராவல் பண்ணிட்டு இருக்கும்போது இந்த forward path டச் பண்ணாம ஏதாச்சும் லூப் இருக்கா? அப்படி இருந்ததுனா அதோட கெயின் என்ன சொல்லுங்க அப்படி நான் கேக்குறேன். See, when I am going with it, see, this is the forward path 1. Here we have a loop. See there, here we have a loop. In the loop, in the forward path touch பண்ணிட்டு இருக்கா? No. This forward path is going here, whereas this loop is separated. In the forward path க்கு இந்த லூப்புக்கு சம்பந்தமே இல்ல. So, loop gain product which are not touching the selected forward path அப்படி கேட்டாங்கன்னா, so this is the loop gain. For an example, some value will be given to you. இந்த loop ஓட gain எவ்வளவு? 2 into minus 3 is going to be minus 6. This is the loop gain product which are not touching the selected forward path. In the same way, if you are going with the forward path 2, see, forward path 2 க்கும் இந்த loop க்கு ஏதாவது சம்பந்தம் இருக்கா? No. So this is called a non-touching. Selected forward path touch பண்ணாம இருக்க loop இது, right? So the question is, if I am asking, when I am going with the forward path 2, find out the gain product, that is gain product, loop gain product which are not touching the selected forward path, In that case, what will you do? So some example will be given, 2 minus 4, like that will be given. So when I am going with this forward path, find out the loop gain product which are not touching the selected forward path. While going with the 2, 1 will become what? In the forward path குள்ள நீங்க போகும்போது இந்த லூப் வந்து என்ன ஆகுது? இந்த forward path டச் பண்ணல. அதே மாதிரி இந்த forward path குள்ள போகும்போது இந்த லூப் வந்து இந்த forward path டச் பண்ணல. So when I am going with when we are taking forward path 2 as your reference, under that condition, loop gain product which are not touching the selected, இந்த select பண்ண forward path டச் பண்ணாம ஏதாச்சும் இருக்கா? Yes, one loop will be there. அதோட gain எவ்வளவு? -8. So that is the meaning of loop gain which are not touching the selected forward path. In the same way, suppose the question is, let me keep one more loop here. 1 minus 1. The question is loop gain, right? The question is loop gain product, that is loop gain product, that is two loop gain product. Let me make the rewrite the sentence, right? Two non-touching loop gain, right? Two product of two non-touching loop gains, right? Product of two non-touching loop gains which are not touching the selected forward path. Product of two non-touching loops. Product of two non-touching loop gains. Some small interruption, right? Similarly, if we have seen, this is called two non-touching loops. Yes or no? So that is loop 1. Let me call it as loop 1. Let me call it as loop 2. I have node 1, node 2. Let me call it as node 3, node 4. Now see that these two loops are called non-touching loops. At the same time, if I am going with the second forward path, now the question is find out the gain products, right? That is gain product of two non-touching loops which are not touching the selected forward path. Find out the gain product of two non-touching loops which are not touching the selected forward path. When in the render product, for an example here, I have 2 here, I have 3 here, I have 2 here, and here it was written as 3. So product of loop number 1. This is loop 1 and this is loop 2, right? This product 2 into 3, 6. This product 2 into 3, that is 6. Now the question is find out the gain product of non-touching loops which are not touching the selected forward path. Which are not touching the selected forward path, right? So 6 into 6 is going to be how much? 36 is your answer. In the same way, you can also keep 3 loops. Find out the gain product of 3 non-touching loops which are not touching the selected forward path. Which are not touching the selected forward path. You have to find out in the forward path reference and the forward path touch பண்ணாம loops. 3 non-touching loop irukka. In the forward path touch பண்ணாம 3 non-touching loops irundhadhu appadina you can identify. If it is not that, then keep it 0. If it is not that, then simply keep 0. Clear? So that is all about basics. Now let me introduce Mason gain formula so that you will get the very clear idea. Mason gain actually is the inventor. That is small tool. That tool will going to help us to get the relationship between the input and output of a very big complicated system. You know the beauty of Mason gain formula. A very big complicated system will be simplified in a fraction of second. Within a fraction of second, within 30 or 40 seconds, you will get the simplified block diagram of a big system. That is the beauty of that mathematical tool. Let me write the mathematical equation first. So try to first slowly inject it, and then while solving the problem, I will come to know, right? I will let you know how to collect the terms and how to get the meaning of that equation. Clear? Right. First, I will write the general meaning of Mason gain formula. Right. First, Mason gain formula. Right. So that is going to be what? Mason gain formula. Right. Let me write the Mason gain formula. Slowly inject, right? You don't need to just first observe, right? What I am trying to do, I am trying to calculate the overall transfer function of a given block diagram, right? With the help of Mason gain formula. In Mason gain formula, we have summation k is equal to I to p. I am writing that. See, let me write 1 to p. Now here I am going to return something that is del k, and here I am going to write pk, right? Of course, we will go up to n. That is better, because both p are not same, you will be confused. I am starting from k and this is summation, right? We will see. First, this is the formula. In the denominator, I have something called a del. Let us expand the discussion. This is the general formula. I have something. In the numerator, I have summation k equal to 1 to n into what? Del k into pk. In the denominator, I have del. Sir, what is this? It's a small equation. Let us extend this equation. You know what is beginning of this equation? Now take this equation once, right? Del. Let me take del outside. Let me extend this del. Actually, whichever the term, if I find any polynomial equation in the denominator of a transfer function, that is called what? Characteristic equation. Of course, this del is known as characteristic equation of the system, right? Let us see. Now, transfer function we already discussed. So, in that case, I clearly told you transfer function characteristic equation is known as the polynomial equation of the denominator of the transfer function. It's nothing but what? Characteristic equation. They are going to play a role with our system. First, that's why I am defining the characteristic equation, and then I will tell you what do you mean by del k and pk. First, I should try to get the meaning, right? Visualize the things. Characteristic equation can be written as 1 minus. First is the sum of individual loop gains. First, write it, then you will get the clear idea. Sum of individual loop gains. First term is sum of integer loop gains. 1 minus sum of integer loop gains plus second thing is sum of gain products. Gain products of, make this sentence clearly, sum of gain products of two non-touching loops. Sum of the gain products of two non-touching loops. Sum of the gain product of two non-touching loops. That is the second term. And the third term is, right, actually here, sum of gain product of two non-touching loops. 1 minus sum of integer loop gains plus sum of gain products of two non-touching loops, right? Plus, once again, see, sorry, 1 minus and then plus and then again minus. Again you have to repeat the same word. And then we know sum of gain product of, same thing you can repeat, sum of gain product of three non-touching loops. Sum of the gain products of three non-touching loops, and then you can repeat 1 minus plus minus again plus again sum of gain product of four non-touching loops and so on. This is the general formula for del. Just to slowly inject, then you will get the meaning, right? Don't think too much because it's a tool. It's a tool. There is no physical realization, right? I am going to use this tool to reduce the big black to put into the, right? A big black will going to be put into the single black. Let us see the beauty of your black diagram later, right? First, a signal flow graph. First, let me take del k. In the same way, del k also will be defined as, right? Del k formula, the formula del k, but with a small injection, small difference. Let us see 1 minus first terms. Once again, same sum of integer loop gains only. This is also going to be what? Sum of integer loop gains. Sum of integer loop gains with this. Write one more sentence. Which are not touching the selected forward path. Which are not touching. Which are not, right? Which are not touching the selected forward path. Which are not touching the selected forward path. That is the beauty, right? Which are not touching the selected forward path. Should try to get the meaning, right? Sum of integer loop gains only, but which are not touching the selected forward path, right? Plus 1 minus and then plus again repeat the same formula. Sum of gain product of two non-touching loops. Sum of gain product of two non-touching loops. Sum of gain product of two non-touching loops which are not touching the selected forward path. Once again, which are, the statement is which are not touching the selected forward path. Which are not touching the selected forward path. Which are not touching the selected forward path. Now you can repeat the same sentence. See there, 1 minus sum of integer loop gains which are not touching the selected forward path plus sum of gain product of two non-touching loops which are not touching the selected forward path, and then once again put minus 1 minus and then plus again minus sum of gain product of sum of gain product of three non-touching loops which are not touching the selected forward path, and then put plus. Write the same sentence for 4. Sum of gain product of four non-touching loops which are not touching the selected forward path, and so on. Clear? That is the general formula for del k. You will come to know the meaning as soon as, right? That is as soon as possible. First, should try to register slowly inject the tools, right, into your mind. Then we can visualize. Similarly, pk is nothing but gain product of kth forward path. Gain product, now we know the meaning. We know the meaning of gain product of kth forward path. Gain product of kth forward path. What do you mean by gain product? We know, right? If I have a line, in that line all your gain will be simply multiplied. I have 2, 3, 4, 5, right? So multiplication. This is called gain product of selected forward path. Here I took kth forward path, right? You select forward path, that is called gain product. Of the selected forward path, you can write. Here I am taking k is my selected forward path, so I am putting kth forward path. That's all. Clear? So this is general formula. Let us see how to apply this formula, right? How to apply this formula to solve the problems, right? Now I will take one example. Should try to visualize these things, right? Should try to visualize. I hope you all understand the tool, right? I hope that is what I learned some what I can relation, right? Source, what is the meaning of source? What is the meaning of sink, right? Of course, link, don't use source, and we are going to use sink. Sink is going to be our output, right? And then we are going to use our loops and gains, right? Let us see one by one all those things. So for an example, I will take one formula here. That is, I will take one circuit. Some diagram will be given like this. Some diagram will be given like that, right? And it will be going like this. Something is given like that. And then here I will select one line, one forward path, of course, and I am going to select one more line here. Now, what it was done? This diagram will be given to you, and given it is R, and they took C, right? In that line, they are given the arrow mark. Arrow mark will be clearly given to you, right? Arrow mark will be clearly given to you. Let's see what will happen, right? So this arrow mark, let me take like this, right? Of course, here I am going to consider one more arrow mark. Let us substitute some values. Values also given. Let us assume 1, 2. Let me take -3, right? Let us take -1, 2, 1. Let us take 3. Of course, let me select 1. So this is also going to be 1. Something will be given like that, right? Now the question is, you are requested to find out the overall transfer function. That's all for the given signal flow graph. First of all, we have to identify. First, write down the formula. Okay, sir. Let me solve this question with the help of the formula. Now, what is the formula? Max and gain formula is summation k is equal to 1 to n, and the formula is what? Del k, pk. In the denominator, I should give del. Now, the thing is, what do we mean by this del k into pk? Right? Here, k denotes the number of forward paths. K denotes the number of forward paths. You should go, sir. How many forward paths are there? Forward path in the sense, it is the path in which we can reach the output from input. Yes or no? Like if I observe, I am starting from here. If I want to follow, I can go like this. If in the path I forward in the far, see there I am just following. In the arrow mark I follow, I can reach the output forward path 1. Similarly, I am going here, I am going here, I am going here. I can go like this, I can go like this. Again, you can reach the forward path, sorry, output, that is called forward path 2. Is there any other path to reach the output? No. See there, you can go like this, you can come here, you can also get back here, again you can go like this, but that is wrong. Why? Forward path, repeated nodes are not allowed. Nodes won't be repeated, that is very important, right? So I have two forward paths. If you have two forward paths, then the numerator can be written as del 1 into P1 plus del 2 into P2. Other meaning your k can go from 1 to 2. Totally you can select two values. Why? Because two forward path. Now k equal to 1 del 1 into P1 plus summation only plus summation plus next value del 2 into P2. Again, if I have three forward paths, suppose if you have three forward paths, then you have one more term plus del 3 P3. That's all. Denominator is del 1. This is the value that we are going to estimate now. Next thing, we have to calculate the value of del 1, P1, del 2, P2, and then del. We have to visualize all these things, right? Now, why do one thing? First, calculate the value of del. First, calculate the value of del, and then we will take rest of all things, so that you will get the clear idea, right? First, we will estimate the value of del. How to calculate the value of del? Let us see. First, I will write the formula for del. RT visa, right? So del is the formula sum of integer loop gains, right? So del can be written as 1 minus sum of integer loop gains, and then plus sum of product of two non-touching loop gains, and then sum of product of three non-touching loop gains, and so on. Yes or no? Now take the whole diagram. Take the whole diagram. First to find out one by one. Upper to know the del, first I should keep 1 minus sum of integer loops, right? Loops. First identify the number of loops. Loops in the sense starting and terminating point are going to be same, right? So in that point of view, if I start from here, I can go like this. I can come back here, same point. So it can be treated as a loop. Let me consider loop 1. Again, see there, one more loop will be there. See there, you can start from here, you can reach the same point. It can also be treated as a loop. Is there any other loop apart from that? No. Loop in the sense starting point and terminating point is same or no. If you loop create repeated nodes are not allowed. I am selecting this node, I am crossing this node only once, again I am getting back. Of course, it can be treated as a perfect loop. I am starting from here, I can go here, again you can getting back. It can be treated as a perfect loop. Now, calculate the value of loop gain 1. L1 gain let me call it as gain 1, L1. இதுல loop gain எப்படி கால்குலேட் பண்ணுவீங்க product of இதுல gain எவ்வளவு இருக்கு -3 into 1 so that is going to be -3 similarly find out the value of L2 is what see there L2 will be here first name if you have any doubts just nodes க்கு வந்து நேம் வெச்சுக்கோங்க right node 1 node 2 right you can name them sir node 3 node 4 node 5 node 6 so loop 1 right loop 1 ல gain வந்து நம்ம யாரை கால்குலேட் பண்ணிருக்கோம் node 1 and node 2 right in between node 1 and 2 we kept our loop 1 in my loop 1 gain is -3 similarly loop 2 ல எந்தெந்த நோட்ஸ் நம்ம யூஸ் பண்ணிருக்கோம் 2 5 and 4 and gain ஓட வேல்யூ எவ்வளவு 2 into -1 so that is going to be -2 and correspondent nodes loop 2 ஓட நோட்ஸ் யாரு 4 5 that is the correspondent nodes of loop 2 now see there loop 1 and loop 2 is there that is called integer loop gains and the second thing is find the sum of product of see first one let me write the equation here but del நம்ம எப்படி எழுதுவோம் del can be written as see del give like this del can be written as 1 minus sum of integer loop gains loop 1 ஓட gain sum னா addition sum of integer loop gain L1 plus L2 right only two loops are there other sum integer loop gains add பண்ணி போடணும் right so -3 -2 will become -5 sum of integer loop gains 1 minus sum of integer loop gains plus அடுத்த ஃபார்முலா என்ன பார்த்தோம் sum of product of two non touching right sum of product of two non touching loop gains first sum அப்படிங்கிறது என்னன்னா product of two non touching loop gains எல்லாத்தையும் நம்ம ஆட் பண்ணனும் அப்படினா மீனிங் என்ன for example I have one loop here they are not touching each other அப்ப இவங்க ரெண்டு பேரையும் நம்ம என்ன பண்ணனும் இதோட கெயினை ஃபைண்ட் பண்ணனும் இவங்க ரெண்டு பேரையும் மல்டிப்ளை பண்ணினா that is called what product of two non touching loops அதுக்கு அப்புறம் என்ன பண்ணோம் இதே மாதிரி one more pair இருக்கு சார் அவங்களும் டச்சிங் கிடையாது தனித்தனியா இருக்காங்க அப்படினா அவங்களோட ப்ராடக்ட்டையும் ஃபைண்ட் பண்ணிட்டு இப்போ ரிசல்ட் வந்து இவங்க ரெண்டு பேரையும் ஆட் பண்ணனும் that is the meaning of sum of product of two non touching loop gains separated two loops தனித்தனியா இருக்கு சார் இத நீங்க தனியா மல்டிப்ளை பண்ணீங்கன்னா இத நீங்க தனியா மல்டிப்ளை பண்ணி you can add them see let me explain one more time one loop like this தனித்தனியா see that these two loops are not interrupt each other let me name them node 1 node 2 node 3 node 4 node 5 node 6 இப்படி எடுத்துக்கலாம் in between node 1 and 2 I have a loop in between 3 and 4 I have one more loop in between 5 and 6 I have one more loop these two loops are not touching they are called அப்ப இவங்க ரெண்டு பேரையும் மல்டிப்ளை பண்ணிக்கலாம் அதே மாதிரி இந்த ரெண்டு லூப்பும் not touching அப்ப இவங்க ரெண்டு பேரையும் மல்டிப்ளை பண்ணிக்கலாம் அதே மாதிரி இந்த ரெண்டு லூப்பும் not touching இவங்க ரெண்டு பேரையும் மல்டிப்ளை பண்ணிக்கலாம் two non touching loops product இந்த மாதிரி தனித்தனியா மல்டிப்ளை பண்ணதுக்கு அப்புறம் எல்லாத்தையும் ஆட் பண்ணீங்கன்னா that is called sum of product of two non touching loop gains clear so அப்ப இப்போ பாருங்க here we have only two loops loop 1 ஓட நோட்ஸ் யாரு 1 2 loop 2 ஓட நோட்ஸ் யாரு 4 5 so ரெண்டு நோட்ஸ் நடுவுல சம்பந்தமே கிடையாது right so they are not touching each other so you can find out the just ஒரே ஒரு non touching loops தான் இருக்கு right one pair of non touching loop only there right இப்போ two pair இருந்ததுனா ரெண்டுத்தையும் ஆட் பண்ணலாம் like two pair அப்படினா sir this is one pair this is one more pair அந்த மாதிரி வந்ததுனா இத தனியா ஃபைண்ட் பண்ணிட்டு அதுக்கு அப்புறம் நம்ம ஆட் பண்ணலாம் but here it is not like that I have only one pair and they are not touching right they are not touching அப்ப ரெண்டுத்தையும் நீங்க என்ன பண்ணீங்கன்னா directly you can multiply them right product of non touching loops -2 into -3 will become minus plus 6 so 3 இதுக்கு அப்புறம் என்ன வரும் 1 minus sum of integer loop gains plus அடுத்து என்ன வரும் product of that is sum of product of two non touching loop gains and then sum of product of three non touching loop gains three loops irukka no so you can just start with this so that is going to be 1 minus of minus become plus 5 plus 6 so that is going to be 12 so in the denominator del can be replaced by 12 now in the numerator let us go to the numerator del 1 அப்படினா என்ன we saw the formula right so the value of del 1 can be written as let me write these things and I will explain once again right so del 1 we know the same formula this formula is actually we have two forward paths here yes or no so del 1 that is the forward path 1 இப்போ del 1 formula என்ன 1 minus sum of integer loop gain which are not touching the selected forward path now selected forward path is this one I am going in this way இப்போ நீங்க இந்த forward path வழியா போனீங்க அப்படினா இந்த லூப் வந்து நீங்க கிராஸ் பண்ணீங்க yes or no so in this forward path does not touching this loop yes or no இந்த லூப் அது டச் பண்ணி தான் போகுது ஆனா இந்த லூப் அது டச் பண்ணல அப்படினா மீனிங் என்ன del 1 equal to 1 minus sum of integer loop gain sum அப்படிங்கிறது ஒரு ரெண்டு மூணு லூப் வந்து இந்த ஃபார்வர்ட் பாத்தை டச் பண்ணாம இருக்கு சார், இங்க ஒரு லூப் இருக்கு, இங்க ஒரு லூப் இருக்கு, அந்த மாதிரி இருந்தது அப்படின்னா அது எல்லாத்தையுமே நீங்க எடுத்து நீங்க போடலாம், சம் பண்ணிக்கலாம். பட் இங்க ஒரே ஒரு லூப் தான் இருக்கு, அந்த லூப் மட்டும் தான் டச் பண்ணாம இருக்கு. அப்ப இது மட்டும் தான் இங்க வரும். எவ்வளவு வரும்? 2 into -1, that is -2. 1 minus sum of integer loop gain which are not touching the selected forward path. அதுக்கப்புறம் செகண்ட் டேர்ம் என்ன பார்த்தோம்? 1 minus அதுக்கப்புறம் plus sum of integer, that is sum of product of two non touching loop gain which are not touching the selected forward path. நம்ம இந்த forward pathல இருந்து is there any two loops இருக்கா? ரெண்டு லூப் இத டச் பண்ணாம இருக்கணும், அவங்களுக்குள்ளே டச்சிங் இல்லாம இருக்கணும். If I have to keep two loops like that, ஆனா இந்த two loop நடுவுல not touching, they are called non touching loops which are not touching the selected forward path. இந்த forward path டச் பண்ணாம தனியா எங்கயாச்சும் இருந்தா I can accept. But here அந்த மாதிரி லூப்லாம் கிடையாது, ஒரே லூப் தான் இருக்கு, அந்த ஒரு லூப் மட்டும் தான் இத டச் பண்ணாம இருக்கு. So you can consider only one, that is sufficient, right? So del 1 is going to be what? Minus into minus become plus 2, that is going to be 3 மொத்தமா. Del 2 is going to be del 2 once again, del 2 is second forward path, right? Second forward path will be 1 minus once again sum of integer loop gain which are not touching the selected forward path. இந்த forward path டச் பண்ணாம இருக்கிறது யாரு? only this person. அதோட வேல்யூ எவ்வளவு? 1 into -3, so that is going to be -3, so this value is going to be 4. I hope you all are getting clear idea now. So similarly del 1 del 2 is calculate the value of p1 now. p1 is what? p1 is nothing but product of the selected forward path. p1 அப்படினா forward path 1 அதோட gain product. இந்த forward path 1 ல யாரெல்லாம் இருக்கா? 1 into 2 into -3 into 2 இதெல்லாம் மல்டிப்ளை பண்ணினா you will get the p1. So p1 is equal to 1 into 2 into -3 into 2 into 1. You should go like this. Gain product of the selected forward path, right? Now what is answer? 2 into 2 4, 4 into -3 will become -12. Similarly p2 calculate பண்ணுங்க. p2 will be equal to, you have to go with the second forward path, this one. யாரெல்லாம் இருக்கா? 1 into 1 into 2 into 3 into 1, so that is going to be 6, மொத்தமா 6, right? Now you can substitute all these values. Del 1 is going to be how much? 3. p1 is going to be how much? p1 is 12, yeah, p1 is 12, right? So 3 times of 12 become 36, so let me directly substitute. 3 into 12 become 36. Del 2 into p2, del 2 is how much? Del 2 is 4, p2 is 6, 4 times of 6 will be 24, so directly I can substitute. Now 36 plus 24 will become 60, so it will become 60 by 12, 60 by 12 become 5 times of 12 will be 60. So the correct answer for our transfer function for this question is going to be 5 times of 12 will be 6. That is the answer for the given question. So that is how we are applying our Maxent gain formula, right? So in the next lecture we will see some other examples, right, for with this Maxent gain formula, so that you will get the clear idea. Thank you all.